Welcome to our channel. Today we're diving deep into the mysteries of Neptune, the farthest planet in our solar system. Get ready to be amazed by these incredible facts. Neptune, a giant ball of ice and gas with supersonic winds and mysteries galore, beckons us from the edge of our solar system. Buckle up as we journey to this distant world, where we'll uncover its secrets and marvel at its awe-inspiring nature. So, just how far away are we talking about? Well, Neptune sits approximately 4.5 billion kilometers from the Sun. To put that into perspective, if the Earth were a grape, the Sun would be a basketball, and Neptune would be a blueberry. About 2.5 miles away. That's a whole lot of cosmic backyard. Being so far from the Sun's warmth, Neptune is a frigid world. Imagine the most bone-chilling cold you've ever felt. Now multiply that by about 100. Despite its distance and chilly disposition, Neptune is a dynamic and fascinating world. It's a gas giant, much like Jupiter and Saturn, with swirling storms and a symphony of atmospheric activity. Hold on to your hats, folks, because Neptune has the fastest winds in the solar system. We're talking speeds of up to 1,200 miles per hour. That's twice the speed of sound. To give you an idea, the strongest hurricanes on Earth top out at around 200 miles per hour. These winds whip around Neptune's atmosphere, creating massive storms that dwarf anything we see on Earth. Picture Neptune as a giant cosmic blender, with its atmosphere churning and swirling at breakneck speeds. Now, remember Jupiter's Great Red Spot? That massive swirling storm that's been raging for centuries? Well, Neptune has its own version, dubbed the Great Dark Spot. This storm, first observed by Voyager 2 in 1989, was so large it could have swallowed the entire Earth. However, unlike Jupiter's long-lived storm, the Great Dark Spot is a bit more elusive. When the Hubble Space Telescope went looking for it in 1994, it had vanished. This disappearance and reappearance of dark spots suggest that Neptune's atmosphere is a highly dynamic and ever-changing environment. These dark spots are thought to be areas of high pressure, similar to anticyclones on Earth. Now here's a mind-blowing fact. Neptune was the first planet discovered not by observation, but by mathematical prediction. For centuries, astronomers had been observing Uranus, the seventh planet from the Sun, and they noticed some strange wobbles in its orbit. These wobbles couldn't be explained by the gravitational pull of the known planets. So, some brilliant minds, namely Urbain Le Verrier and John Couch Adams, independently concluded that there must be another unseen planet tugging on Uranus with its gravity. In 1846, using Le Verrier's calculations, Johann Galle pointed his telescope to the predicted location, and boom, there was Neptune. Have you ever wondered why Neptune is such a brilliant shade of blue? The answer lies in the planet's unique atmospheric composition. Neptune's atmosphere is primarily made up of hydrogen and helium, just like Jupiter and Saturn. But what sets Neptune apart is the presence of methane in its upper atmosphere. Methane is a gas that absorbs red light and reflects blue light. So as sunlight reaches Neptune, the methane in its atmosphere absorbs the red wavelengths, leaving behind the beautiful blue hues that we see. It's like a giant cosmic mirror, reflecting only the blue part of the light spectrum. Neptune isn't alone out there in the vastness of space. It's got a posse of 14 known moons, each with its own story to tell. But perhaps the most fascinating of them all is Triton, Neptune's largest moon and a true oddball in the solar system. Triton is unique for a couple of reasons. First, it has a retrograde orbit, meaning it orbits Neptune in the opposite direction of the planet's rotation. This suggests that Triton wasn't formed in the same region as Neptune, but was captured by the planet's gravity at some point in the distant past. Second, Triton is geologically active, with geysers that erupt nitrogen gas from its icy surface. When we think of rings in the solar system, Saturn immediately comes to mind, right? But did you know that Neptune also has rings? They're not as grandiose or as easily visible as Saturn's, but they're there nonetheless. Neptune's rings are made up of dust and small rock particles, thought to be remnants of comets, asteroids, or shattered moons. These particles clump together, forming faint arcs and rings around the planet. Saturn's rings are made up mostly of ice, which reflects a lot of light. Neptune's rings, on the other hand, are composed of darker materials, making them harder to see. Remember how we talked about Neptune being cold? With temperatures plummeting to minus 214 degrees Celsius or minus 353 degrees Fahrenheit, Neptune is one of the coldest places in our solar system. To put that into perspective, the coldest temperature ever recorded on Earth was minus 89 degrees Celsius, or minus 128 degrees Fahrenheit, in Antarctica. This extreme cold is due to Neptune's vast distance from the Sun. Being so far away, Neptune receives only a tiny fraction of the sunlight that we receive here on Earth. Time works a little differently on Neptune. A day on Neptune, the time it takes for the planet to rotate once on its axis, lasts about 16 Earth hours. But here's where things get interesting. A year on Neptune, the time it takes for the planet to complete one orbit around the Sun, lasts a whopping 165 Earth years. We've already touched upon the incredible story of Neptune's discovery, but it's worth revisiting in a bit more detail. The discovery of Neptune was a watershed moment in astronomy. It was the first time a planet was discovered not by observation, but by mathematical prediction. It all started with those pesky wobbles in Uranus's orbit. Enter Urbain Le Verrier and John Couch Adams, two brilliant mathematicians who independently tackled the problem. They hypothesized that the gravitational pull of an as-yet undiscovered planet must be the culprit. Here's a curious thing about Neptune. It radiates more heat than it receives from the Sun. Scientists believe that Neptune has an internal heat source. This internal heat is thought to be left over from the planet's formation, generated by the slow gravitational contraction of its core. Even though it's no longer being heated by an external source, it still radiates heat into its surroundings. Neptune's internal heat is thought to be responsible for its dynamic atmosphere and those crazy supersonic winds. Remember Triton, Neptune's peculiar moon with a retrograde orbit? Well, Triton's future might be even more dramatic than its past. Triton is slowly spiraling inward towards Neptune. Over millions of years, as Triton gets closer and closer to Neptune, the gravitational forces between them will intensify. Eventually, scientists predict that Triton will cross Neptune's Roche limit. When Triton crosses this limit, Neptune's gravity will rip it apart, scattering its icy remnants into a spectacular ring system. Earth's magnetic field, generated by our planet's molten iron core, acts like a giant shield, protecting us from harmful solar radiation. Neptune also has a magnetic field, but it's a bit of an oddball. For starters, Neptune's magnetic field is tilted at a whopping 47 degrees relative to its rotational axis. What's more, Neptune's magnetic field doesn't even originate from its core, like Earth's. Instead, it's thought to be generated by the movement of electrically conductive fluids such as water and ammonia deeper within the planet's interior. Diamonds in the sky? It might sound like a line from a cheesy love song, but it could be a reality on Neptune. Deep within Neptune's atmosphere, conditions are ripe for the formation of diamonds. Neptune's atmosphere is rich in methane. Under the immense pressure and heat found deep within the planet's interior, methane molecules can be broken down, releasing carbon atoms. These carbon atoms can then bond together, forming diamonds. We're talking about diamonds the size of hailstones, raining down through Neptune's atmosphere. Earth's axial tilt of 23.5 degrees is what gives us our seasons. Neptune also has an axial tilt, but it's even more extreme than Earth's. Neptune's axis is tilted at 28.32 degrees, giving it seasons similar to Earth's, though much longer due to the planet's long orbital period. Imagine seasons that last for over 40 Earth years. This tilt, combined with Neptune's long orbital period, means that its seasons are incredibly long and drawn out. During a Neptunian summer, one hemisphere basks in continuous sunlight for decades, while the other hemisphere is shrouded in darkness. Thanks for watching. If you enjoyed learning about Neptune, make sure to like, subscribe, and hit the bell icon for more fascinating space facts. See you next time! We've journeyed to the edge of our solar system and uncovered the secrets of Neptune, a world of supersonic winds, elusive storms, and a potential for diamond rain. But this is just the tip of the cosmic iceberg. There's so much more to explore out there in the vast expanse of space. So keep your curiosity alive, keep asking questions, and keep looking up at the stars.